Hello. So in the last video, we have written or we have obtained this expression that is for coefficient of viscosity. I hope you remember that this is in magnitude. The negative sign I am right taking out because it tells only the direction, but I don't bother about it because it's only magnitude. Now, my first task is to write the dimensional formula. Okay, what do you think? What can be the dimensional formula for coefficient of viscosity? I'm directly writing, you prove it, how m raised to 1, l raised to -1, t raised to -1. So what you need to do, substitute a ka dimension, f ka dimension, a delta x is position only, v is velocity. So you can substitute their dimensions and let us see whether you are getting the same dimension formula or not. Another thing which I would like to highlight, that I hope you remember eta even in mechanical properties of solids as modulus of rigidity modulus or modulus of elasticity, right? So don't get confused. If I'm using it in terms of fluids, it means coefficient of viscosity. If I'm using here, it means that if I'm using in solids, it means that modulus of elasticity or rigidity modulus. Okay. Now let's begin our another discussion on units, kinds of units. Both we will see CGS and as well as SI. What do you think? What can be? Okay, can someone tell me what is CGS units? Write down, look at the formula, write down the CGS unit and as well as SI units. I'm not taking out the formula. If you see, eta is force, position, and as well as area, and as well as velocity. So what can you write? Eta, SI unit for CGS unit for eta. By looking at the formula, force we measure in dynes, right? Delta x, which is nothing but position, which we measure in centimeters, upon area, again centimeter square, again velocity centimeter per second. So you can see that. Similarly, write down for SI. So eta Newton meter, meter square, meter per second. I hope you are understanding how we are writing the units. So centimeter, centimeter we cancel here, meter, meter we cancel. So we left out with dyne, centimeter power -2, second power 1, which I can kindly write like this. So Newton meter power -2 second. So this is the SI unit, and this is the CGS unit. What else we need to mention? Oh yeah, what else? This dyne centimeter power -2 second, we call it as poise. Okay, call it as poise. When as in terms of Newton meter power -2 second, we call it as Poisely. These are the scientist names. Okay, we call it as Poisely. Check the spelling. Poisely. Okay, yeah. So there is a relation. What do you think? What can be the relation between this poise and Poisely? Can someone tell me the relationship? If you don't know, try to establish. That's it. Relationship between poise and Poisely. What do you think? How can one establish this relation? So remember that here we have 1 Newton meter square. Write down that 1 Newton meter power -2 second, isn't it? What we are calling? We are calling it as Poisely. This is 1 Poisely. Correct? Write down. So now try to convert what is Newton in terms of dyne. If you remember, you can directly write 10 power 5 dyne, isn't it? We have learned in unit 1. How about meter? Converting to CGS. Meter means 100 centimeters, right? So I can write 10 power 2 centimeter, but it's not simply centimeter, it is power -2. Then what about the second? What about The second remains the same, isn't it? Now write down the units at a place. 10 power 5, 10 power 2 whole power minus 2, which becomes 10 power minus 4, and second. So the units becomes dyne, so dyne centimeter power minus 2 second, which is nothing but this is nothing but Poisley, isn't it? This is Poise. I'm sorry. This is one Poise. If you look at here, that one Poisley is equals to how many points? 10 power 5 minus 4, so 10. So 10 points. This is the relation between the CGS and SI units of coefficient of viscosity. This is about the relation between them. Let us solve some numericals. I will solve one numerical, which is a simple way I will take, but yeah, numericals on this. I'll also share some problems with you so that you can also solve, and there are some numericals which are given at the end of the exercise. Try to solve them as well. If you have difficulty, you can meet. Okay. Yeah. We have this numerical with us. Please write down the given data first. But you know what is the form? What is the form? What are they expecting us to calculate? They're expecting us to calculate the coefficient of viscosity. So which is nothing but eta is equals to F by A change in position, change in V, which is reciprocal of the velocity. So write down the data. So what are the things has been given? They have given area of the plate as 2.5 into 10 power minus 4 meters square. Is placed on some thick layer of castor oil. The delta X is the difference between the layers, right? So delta X is given as 0.25 to 10 power minus 3 meter. So the force, they have given it as 2.5 Newton is needed to move the plate with the velocity. What is the velocity they are saying? The velocity referring as 3 into 10 power minus 2 meter per second. Now we need to substitute this. Just basic substitution, right? You can see that just basic substitution. Please pay attention during your calculations. You are committing many mistakes there. So force 2.5 Newton times what is the change in position or the layers thickness 0.5 to 10 power minus 3, right? Area 2.5 into 10 power 2.5 into 10 power minus 4, right? Then what else? Delta V is left 3 into 10 power minus 2. Please calculate this and let me know your result. Okay, this is my result I have mentioned here.